Today we want to do a quick review of radians. Remember, we want to learn the unit circle going all the way around 30, 45, and 60 in degrees. 30, 45, and 60 in all four quadrants. And then we wanted to learn those angles in radians as well. The angles that we're trying to learn, 30, 45, and 60-degree reference angles, and the angles on the quadrants, all have very distinctive fraction multiples of pi. So our pi over 2s, the ones that stay pi over 2, that's going to be our 90 and our 270 on our y-axis, the positive and negative y-axis. 1 pi over 2 and 3 pi over 2. The 2 pi over 2 and 4 pi over 2 both simplify to pi and 2 pi. And so that's 180 and 360. Our 45 degrees is pi over 4 in the first quadrant. So we can recognize our 45-degree reference angle by being a multiple of pi over 4. So 45 is pi over 4, 135 is 3 pi over 4. We skipped over 2 pi over 4 because that simplifies to pi over 2. And 2 times 45 is 90. So 3 pi over 4 is 135 in the second quadrant. 4 pi over 4 is equal to pi, or 180. 5 pi over 4, that's the reference angle for 45 degrees. And then 7 pi over 4. So 1, 3, 5, and 7 pi over 4 are your 45-degree reference angles, or your pi over 4 radian reference angles. The other are your 30s and 60s. It's a little bit trickier because your 60 is a multiple of a 30. But if we start with the 60 as being pi over 3, the 4 that we care about are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. We don't need to worry about 3 pi over 3. That's just 180. And we don't need to worry about 6 pi over 3. That's just 360. So if it's a pi over 3, talking about a 60-degree reference angle, or a pi over 3 radian reference angle. And similarly, the 30-degree reference angles all have a pi over 6. 1 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are the 4 numbers you want to recognize as your pi over 6. All the other integer multiples of pi over 6 will get simplified out to something else. So like that, we have 4 pi over 6. 4 pi over 6 is just 2 pi over 3. So 4 pi over 6 is 2 pi over 3. 4 times 30 is 120. So it all fits together. There's a 30, 45, and 60 in quadrant 1, 2, 3, and 4. The other thing that we want to pair this with is what's positive where. In the first quadrant, all trig functions are positive. In the second function, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. So here's another way to remember what's positive. If you go around 1, 2, 3, and 4, you could think all students take calculus. That's not a new rule. If you're like, oh, I don't want to take calculus. It's not a new rule. It's just a way to remember. It could be all students take chemistry. If you don't like that, all students talk cars. I don't know. It doesn't have to be calculus. I base it on calculus because math teacher. So I need to go ahead and get all the way off my back. That's just one way to remember. The other way to remember, you've got to pair this with all the other ways to remember these things. That's just maybe your first way in. Notice that sine is positive in the first and second quadrants because sine is positive where y is positive. Sine is the y coordinate going around the unit circle. X is positive in the first and fourth quadrants. That makes sense. That's cosine is positive in the first and fourth quadrants. Cosine is positive where x is positive. That makes sense because cosine is the x coordinate going around the unit circle. Tangent has this weird pattern where it's positive in the first and third quadrants, That's because tangent is y over x. So tangent is positive when the x and y have the same sign. Either x and y are positive in the first quadrant, same sign, so positive, or x and y are both negative in the third quadrant, same sign, positive. So we want to know our reference angles, our sine, cosine, and tangent, and what's positive. What we want to be able to do is do all the variations of the 2 out of 3 problem. So I have to be able to give you a trig function. And let's say x. Leave out the angle and then give you the ratio. So let's say cosine x is negative √3 over 2. This is a combination of two out of 3 problems. Trig function and ratio will give you a reference angle. Trig function and sine will give you 2 quadrants. So it's two out of 3 problems. Trig function, angle, ratio. Trig function, sine, plus or minus, quadrants. I think I used different colors last time. It's two out of 3 problems. Question? If we want to think about opposite, adjacent, and hypotenuse, then we're thinking in terms of an acute triangle. If we're thinking in terms of acute triangle, then we don't want any of these to be negative. So, but if we want to think in terms of opposite, adjacent, hypotenuse in the context of the unit circle, then the 2 is the hypotenuse. That'll be always positive. It'll be like x or y in the case of cosine, x over the radius, and the radius should always be positive. And then so negative means our x is in the second or third quadrant. So notice I wrote cosine of x is negative √3 over 2. I didn't specify whether I wanted degrees or radians. Usually if I'm using x, I'll want radians. So I might say solve cosine of x equals negative √3 over 2 for x between 0 and 2 pi. If I want x to be between 0 and 2 pi, I'm asking the problem in radians. The 0 doesn't tell us anything, but this means the problem is in radians. In general, I use x for when I want radians and theta when I want degrees, but that's not always reliable and by no means standard, even with me writing the problems. So there's 2 different 2 out of 3 problems. We have cosine and just the ratio, √3 over 2. What angle are we talking about? So for the reference angle, we have cosine and √3 over 2. So we are talking about which angle? Is it 30, 45, or 60? Oh, but the problem's in radians. So instead of 30, what are we going to say? Pi over 6. Next, we have cosine is negative. And where is cosine negative? Cosine is negative in quadrant 2 and quadrant 3. So what I want to do is put pi over 6 in quadrant 2 and quadrant 3. So x equals pi over 6 in quadrant 2 is 150 or 5 pi over 6. Pi over 6 in quadrant 3 is 210 or 7 pi over 6. So the 5 pi over 6 is pi over 6 in quadrant 2. 7 pi over 6 is pi over 6 in quadrant 3. Just two out of 3 problems. Trig, function, angle, and ratio. Trig function, sine, plus or minus, and quadrants. And you put those two together. Here's the problem is in a similar form, although now I've specified theta, and I want you to solve in degrees. We're looking for an angle. I have a trig function, sine, and I have a ratio of √3/2. What angle are we talking about? We're talking about a 60-degree reference angle. We could just leave that in degrees because the problem is stated in degrees. Then the other thing we go for is this, we have sine and it's negative. So what quadrants are we talking about? Quadrant 3 and quadrant 4. So we're just going to grab the 60-degree reference angle in quadrant 3 and quadrant 4. 60 degrees in quadrant 3 is 240. And 60 degrees in quadrant 4 is 300. So 240 is the 60 in quadrant 3. Now, when we learn the problems, we have to learn them forwards and backwards. So I also have to be able to give you different. I have to be able to. You have to know your values. So instead of saying solve, I might just say find the cosine of 4 pi over 3. So in terms of degrees, what's our reference angle? It's an over 3, so the reference angle, whatever the denominator is, that's your reference angle. As long as you've simplified this. Unless I start pulling some shenanigans. What's the cosine of 8 pi over 6? That simplifies to 4 pi over 3. The denominator will tell you what reference angle is if it's one you know. Pi over 3 is a 60-degree reference angle. Because pi is 180. 180 divided by 3 is 60. And what quadrant is 4 pi over 3 in? Let me go up here. I see our 4 pi over 3, which is 240. It's in quadrant 3. So since we are in quadrant 3, is cosine positive or negative? negative for quadrant 3. And what is the cosine of 60? Oops, I spelled 2 wrong. I wrote 2 upside down. The ratio we get from cosine and the reference angle, the sine plus or minus we get from the cosine and the quadrant. We know we're in quadrant 3, so that we're going to have a negative value. And we know we're going to get a 1/2 because a cosine of 60 is 1/2. Now, if the sine of 4 pi over 3 will be negative root 3 over 2. The sine of 60 is root 3 over 2, and sine is negative in the third quadrant. So if I did sine of 4 pi over 3, negative root 3 over 2. No, the sum of their squares is equal to 1. So a 1/2 squared plus a root 3 over 2 squared. Any questions? Is everybody okay? So we want to figure out what the reference angle is, right? So if we go up to our list up above, 4 pi over 3 is 240 degrees. 4 pi over 3 has a 60-degree reference angle. It's in quadrant 3. So 4 pi over 3 is the 60 in quadrant 3. We want to figure out the reference angle and the quadrant when we're looking at an angle. We want reference angle and quadrant. Yeah, 4 pi over 3 radians is 240 degrees. That quadrant is over at 270. You're correct. 240 is before the 270. So 270 would be straight down. So 240 is here in the third quadrant. As we go, remember, we always go from the positive x-axis. So 240 is, we want to know how far we are from the negative x-axis. So the negative x-axis is at 180, and this is at 240. 240 minus 180 puts 60 degrees. It only seems like it's a lot to remember because it's a lot to remember. And you have to remember all of it, all the time, in perfect detail. No problem. Okay. I wanted to offer a different way to organize the information. Yesterday modulo this class, so Thursday, it was all organized around the unit circle, which works for some people because they see the 30s, the 45s, and the 60s. They can see it building up. But other people aren't seeing it with the 30, 45, and 60 with the red, green, and blue band. It just kind of becomes a jumble. So I wanted to separate that out into separate lines. A line for the 60 in quadrant 1, 2, 3, and 4, a 30 in quadrant 1, 2, 3, and 4, and a 45 in quadrant 1, 2, 3, and 4. So it's just a different way of organizing the information. Which one is going to make it stick? And then we're just going to try to point out all the different ways that this stuff is related. 45 is a pi over 4. All the 45-degree reference angles have some multiple of pi over 4 in their rate when we measure it in radians in the 4 different quadrants. All the 30 degrees have a pi over 6 reference angle, and you can see the pi over 6 in all the radian representations. All the 60s are pi over 3, and you can see the pi over 3 in all 4 of their representations. That's another way that we can envision. Uh-oh. Oh, hey, heck. Apparently I didn't recognize. So, well, that was lucky. I forgot to erase apparently last week. But going up from the 0, we've got the 30s, which are the pi over 6s, 1, 5, 7, and 11. We got our pi over 4s up from that, 1, 3, 5, and 7. And above that, we've got our pi over 6 here, pi over 6 up here, 1, 2, 4, and 5. Then we at the top, we have pi over 2 and 3 pi over 2. So instead of going all the way around, maybe visually it's better for you to organize it top and bottom. Sometimes I think of a bow tie method. So here's the red bow tie. It's the flattest one. And then we've got the green bow tie at the 45s. And then we've got the blue bow tie, the tallest one at the 60s. Got to be a lot of different ways of viewing your radiant, of relating your radians and your degrees. In degrees and radians. Any questions? How's everybody okay? Everybody looks stunned. You all look like this. But it's hard to tell. It might just be some math class. That's like Tuesday afternoon, after 4 days. Yes. This is chapter 3. Chapter 3 just showed up today on the homework list for Sunday the 26th. Oh, so you're not behind. If you've done the 4 quizzes on solving right triangles, you are not behind. Chapter 3 was supposed to be due the previous one, but then I forgot to assign it, and nobody read my mind to figure out when they were due. So
I thought I was behind. I'm like, it's not on Sunday.
No.
I was slept.
That's always the paradox of the student who recognizes that homework hasn't been assigned. Do I say something? No. Do I assist the teacher in remembering that the homework has not been assigned, or do I assist the rest of the class to alleviate pressure? Then you have to do the calculation. It's game theory, by the way. This is a game theory because you have to think, okay, is our teacher the kind of teacher that's going to be like, oh, well, I forgot to assign it, so instead of having it assigned a week ago, it's assigned now for tomorrow. And then you're like, oh, Leach wouldn't do that to us. Leach is cool, right? I'm like, oh, no, chapter 5, I haven't even talked about in class, and it's due in 10 minutes, so get started. I kind of don't think I am. I think I'm lawful good. I'm just disorganized. I think that's really what it comes down to. So when you're disorganized, you give the appearance of chaotic nature.
When do you say that?
That's an alignment in Dungeons and Dragons. That's okay. All right. So this is another way of organizing the information. I've got these first 2 lines are your quadrant angles. 0, 90, 180, 273, 60. I separate them out into the pi's, the integer pi's, and the pi over 2s. There's only 2 of them. And then here's your 45-degree line, here's your 30-degree line, and here's your 60-degree line. Now, when you're trying to learn these, it might help to reorganize. Put the 30 up first, and then the 45, and then the 60. That might help to go to pi over 6, pi over 4, and pi over 3. Go from smallest to largest. But some of us, because we're humans, aren't going to see pi over 6, pi over 4, pi over 3 as going from smallest to largest, because you're like, oh, 6, 4, 3, what the hell, man? It's perfectly natural, right? Everybody knows how McDonald's sells quarter-pounder burgers. A&W said, we're going to make bigger ones. We serve third-pound burgers. And people were like, oh, no, I don't want a smaller burger. And A&W's like, oh, motherfucker, that is. And then like they just gave up on it. They gave up on it. That's not how the human mind works. You can't engineer for how people should see things. You got to engineer for how they're gonna see things. You know what I mean? It's like speed limits. You can't put, you have to go, if you could safely go 45 around a curve, you got to put 25 on that curve. Because people are going to see 25 and go 45. That's just how things work. That's how the mind works. So I don't know how you're going to see it. I'm not allowed to look into your mind to see how it works, but you're going to find, you need to find a way to associate the pi over 4 and the 45 and get these four numbers, 45, 135, 225, 315, and associate those with 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And just knock them out like that. This is your new times table. You all know your times tables. This is your times table for trigonometry. So try different organizations of this. Okay. We don't really do things to encourage them to stay. All right, let's take a quick break and then come back and see what else we can do with this. It's more 2 out of 3 games. Let's take a quick break. Come back and talk more trigonometry.